Hello, good morning everyone. So this is I think the sixth YouTube session hosted by me. Yeah, just a second. Okay, so good morning everyone. Myself Priya RK, and this is the sixth YouTube session hosted by me. And this is about the Plus subscription. Before going into the Plus subscription, let me tell you I have 4 years of experience in teaching JEE, NEET, as well as CET examination, and I've produced good number of ranks under my guidance and mentored many of the students towards these exams. So this is about the Plus subscription. We have different plans. We have 12-month plan, 6-month plan, and also 1-month plan is available. 12-month plan cost you around 12,375 rupees. 10-month plan cost you, 6-month plan cost you about 10,125, and there is also a trial price for only the new subscribers, and that is about 2,250 rupees. Okay, so all of you can go for this Plus subscription, and you can use this code PRKLIVE in order to get 10% off, 10% off on the subscription plans. Good morning, Sanjana. Yeah, now why we need to go for Plus subscription? So here we have premium content, doubt clearing sessions are there, live classes are there, quiz will be organized at regular intervals, separate batches will be there, and also DPPs will be given, and also PYQs will be solved. And under single subscription you can have unlimited access to the content. Okay, so today we are going to mainly discuss about electrochemistry, mainly about the electrochemistry. So electrochemistry usually represents the two chemistry. Good morning, Jagan. Thank you for joining. Please stay tuned. Okay, now in this chapter we are basically going to learn about how we can use, how we can make use of chemical reaction and convert the energy of chemical reaction into electrical energy. So basically these concepts we are going to learn from this particular chapter, that is electrochemistry. So here this is a quick short, that is one time revision. The complete course has been dealt on Unacademy platform. You can go for the description of this video. You will get the link to my profile on Unacademy platform, and please follow me and you can watch the entire chapters of different topics in there on my profile. Okay, so today I'm going to revise for next 30 minutes or 35 minutes about the electrochemistry. This will be a revision class. The entire course is available on the Unacademy platform. You can go for the description of this particular video and look for the profile link on the description, right? Okay. So here what we are going to do is we are going to convert chemical energy. Now from where this chemical energy comes? So usually a chemical reaction happens. A chemical reaction happens which releases certain amount of energy. This energy is called as chemical energy. Now this chemical energy can be converted into electric energy. Electric energy. So this is basically any electrochemistry process usually takes place. Next, first topic in this one is electrochemical cell. So here it is a revision. So in short it would be told, entire course is there on Unacademy platform. You can go for the description and click on the link. Electrochemical cell. Electrochemical cell means a cell in which chemical energy is converted into the electrical energy. In this particular vessel or in this particular cell, the entire reaction is going to occur. So what this status looks like? So here we have two different vessels, and in these vessels we have a solution that we call it as electrolyte solution. For example, if I am taking an electrode here on the surface of which the reaction occurs, here also I am taking one electrode. So let me take a very important cell, that is Daniell cell, as the example. So if it is Daniell cell, this would be zinc, this electrode would be zinc, and this solution would be zinc sulfate. And this would be copper, and this solution would be copper sulfate solution, right? Okay, now these two cells, they are connected, and these two solutions, they are linked by a salt bridge. What is the function of salt bridge? Salt bridge usually maintains the electric neutrality. Salt bridge usually maintains the electrical neutrality. Any salt bridge can be taken of KCl, and even some nitrites are there. Okay, so these can be the salt bridge. Okay, now this zinc, if I am taking it as anode, it should be negatively charged. This copper would be positively charged and it will act as cathode. Now, electron flow from zinc to copper. Electron flow from zinc to copper. That means current flows in the opposite direction, that is from copper to zinc. From copper to zinc. Sorry. Now, what reaction actually occurs? And from where these electrons come? Zinc plus copper 2 plus gives Zn2 plus copper. Now here zinc is releasing 2 electrons. Those 2 electrons will be utilized by the copper 2 plus which are present in the solution of copper sulfate, and then this copper which is generated, it will be deposited over this electrode. It will be deposited over this electrode. Now this is called as Daniell cell. This is called as Daniell cell. Now if electrode potential represented by E is equals to 1.1 volt and concentration of Zn2 plus and concentration of Cu2 plus, if it is equals to 1 mole per liter, then this Daniell cell would be called as galvanic cell. This Daniell cell would be called as galvanic cell, or even known as voltaic cell. Okay, so Daniell cell is one in which the anode is the zinc and copper is the cathode, and electron flow takes place from the zinc to the copper, and current flows in the opposite direction, that is from copper to zinc. This is the Daniell cell reaction. But if the electrode potential of this particular cell is 1.1 volt and concentration of Zn2 plus and copper 2 plus is equals to 1 mole per liter, then it would be called as galvanic cell or voltaic cell. Galvanic cell or voltaic cell. Fine. So here what we have? We have electrode potential as 1.1 volt. Now if the potential, if the external potential that is there, that is less than 1.1 volt, then electrons flow usually from zinc to copper. That is what we have seen in this particular diagram. So this is the first one. Electron flows from zinc to copper, and current flow from copper to zinc. Copper to zinc. Likewise, if the external potential is greater than 1.1 volt, then the reaction would reverse. The reaction reverse. How it would be? Electron flow from copper to zinc and current flow from zinc to copper. And if the external potential is greater than 1.1, then we call it as electrolytic cell. From electrochemical cell, it will get converted into electrolytic cell. Electrolytic cell. Okay, now what if the external potential is equals to 1.1 volt? Just now we have seen if external potential is 1.1 volt, what will happen? So this was the first condition. This is the second condition. This is the third condition. So this was electrochemical cell. Electrochemical cell, because external potential applied is less than 1.1. But if it is equal to 1.1, then no flow of electrons would take place. And if no flow of electrons, no flow of current. No flow of current. Okay, so this is the condition for the electrochemical cell and electrolytic cell. Now we have seen here Daniell cell, that is Zn plus CO2 plus gives Zn2 plus copper. Now here we have two types of reaction. This is the overall reaction, correct? Overall reaction. Overall reaction. But here we have two different half cells. So half cells we are studying here. First one is oxidation half cell. Oxidation means release of electrons. Release of electrons. Who is releasing electrons? Zinc. Zn is giving rise to Zn2 plus. That means how many electrons it has released? 2 electrons it has released. Then reduction half cell. Acceptance of electrons. Acceptance of electrons. That is copper 2 plus is taking 2 electrons to give copper. So we can say this reaction, it is a redox reaction, because redox reactions are those in which both oxidation as well as reduction occurs. Oxidation as well as reduction occurs, right? So it is a kind of redox reaction, right? Okay, so this is about the Daniell cell. Moreover, about the Daniell cell. Okay, now coming to what is this electrode potential? This term electrode potential. Now let me go back to the image. One second. Okay, let me go back to this image. So here we have written the electrode is in contact with one of the like salts, like zinc is there, so zinc sulfate, copper is there, therefore copper sulfate. Now there will be a potential difference, there will be a voltage difference between these two, the electrode and the solution, and this potential difference we call it as electrode potential. A potential difference between electrode and electrolyte is called as electrode potential, right? Is called as electrode potential. Next, what is standard electrode potential? Standard electrode potential. Now when the different species involved in the reaction, if their concentrations are equal to unity, if the concentration is equal to unity, then we call it as standard electrode potential. Then we would call it as standard electrode potential, right? If the concentration of different species involved in half cells is a unity, that means 1, then the electrode potential is called as standard electrode potential. Standard electrode potential. So this is about electrode potential and standard electrode potential. Now let us see what is this anode and what is cathode. Okay. So anode is one on which always oxidation takes place. On which always oxidation takes place. And a reduction is one in which, cathode is one on which always a reduction takes place. On which always reduction takes place. So E cell, that is E cell called as cell potential. Cell's potential is equals to E right, means right side electrode minus E left side electrode. E right side electrode minus E left side electrode. Right? That is, you can also call it as E cathode minus E anode. E cathode minus E anode. Okay, that is potential of the cathode minus potential of the anode. Right? So this is about the different concept of cell potential. Okay, let me just see if I have any comments. Good morning, Shafakat. Thank you for joining. Yeah, fine. So let us just see what is there. Next is a very important equation, that is Nernst equation. Nernst equation. Okay, now what is this Nernst equation? Nernst equation is actually used to calculate the potential of a cell. Okay, potential of a cell, and the formula is E cell is equals to E naught cell minus 0.059 upon N log of anode concentration upon concentration of the species at cathode. Right? Now, you might ask me, like, here also we are calculating E cell, here also we are calculating E cell. But here we can calculate E cell when you know the potential of cathode and anode separately. But if you know the concentration of the anode and cathode, then you can use this particular formula. So let us go for one of the questions. Okay. So let me write. Represent the cell in which the following reaction takes place. In which the following reaction takes place. Now what is the reaction? The reaction is Mg plus 2Ag plus in bracket 0.01 m gives Mg2 plus 0.1 m plus 2 Ag, and given E naught cell is equals to 3.17 volt. Calculate the E cell, that is potential of the cell. So here they are asking us to represent the cell. Now what is the meaning of representation of a particular cell? So representation of a particular cell can be written like this. So let us see what is here in this particular cell. Let us taking this as an example. See how we can represent a particular cell. So Mg is there, Ag is there, two reacting species. Mg is getting converted into Mg2 plus. Concentration of Mg2 plus has been given. So representation of the cell would be Mg slash, okay, means magnesium is getting converted into Mg2 plus or in contact with Mg2 plus. Mg2 plus. The slash should be there. And what is the concentration of Mg2 plus given in the question? 0.1 mole. Then we have salt bridge, and salt bridge is represented by double lines or double slash. We have Ag plus getting converted into Ag. Ag plus, concentration of Ag plus is given 0.01 m slash, it is getting converted into Ag. So this is the representation of any particular cell. From what to what it is getting converted, and if any concentration is given, that you have to mention up, and then take a salt bridge and the other species. Okay, the other species. Now what else they are asking us to calculate? Calculate E cell. We know from this particular formula of Nernst equation, E cell is equals to E naught cell. E cell is equals to E naught cell minus 0.059. The derivation of this, everything is being taken in the complete course. You can go for the link of this particular course, and you can find the link in the description box, and everything has been already jotted out. We are going to just revise in this particular class. Okay, so this is the formula. E cell we need to calculate, we don't have its value. E naught cell given in the question 3.17 volt minus 0.059. N represents number of electron changes. N represents number of electron changes. Ag plus is getting converted into Ag. Okay, here you may get confused, but you can see here Mg is getting converted into Mg2 plus. That means how many electrons are being removed? 2 electrons has been released. Log of anode, which will act as anode? The oxidation species will act as the anode. Oxidation species is the anode, because always on anode oxidation takes place. So here it would be this concentration, that is 0.1 mole divided by 0.01 mole. Mole and molarity, right? Cancelled. 0.1 divided by 0.01. It is nothing but 10, right? This is log 10. E cell is equals to 3.17 volt minus 0.059 upon 2 log 10. Okay, let me go for the next one. E cell is equals to, E naught cell was how much? 3.17 minus 0.059 divided by 2 log 10. This was the equation we had written. Log 10 is 1, right? Log 10 is 1. 3.17 minus 0.059 divided by 2. 0.059 divided by 2. That would be 0.0295 into log 10 is 1. So E cell is equals to, if you just subtract these values, this value into this, it is going to be 0.0295, because into 1 will not change it, right? So 3.17 minus 0.0295. Your answer is 3. This was volt, right? Okay, 3.14 volt. 3.14 volt. Hope all of you understood this question. Yes. Next one very important formula is equilibrium constant calculation from Nernst equation. Equilibrium constant. This is also very important. Equilibrium constant from Nernst equation. So in equilibrium chapter we have learned about this equilibrium constant, that is represented by K, right? So likewise here also we can calculate it from Nernst equation. Nernst equation. And the formula is at equilibrium, E cell is equals to 0. E cell is equals to 0. What is the formula now we have? E cell is equals to E naught cell minus 0.059 upon N log of concentration of a species at anode upon concentration of species at cathode. Now why I have written here? Because at equilibrium, E cell is equals to 0. Where our formula is E cell is equals to E naught cell minus 0.0959 upon N log of concentration of anode upon cathode. So in spite of E cell, I will write here as 0. Now what I can do, I can shift this entire term on the other side, so it will become positive. So if I shift it on the other side, the other side will remain only E cell. So E naught cell is equals to 0.059 upon N log of concentration of anode upon cathode. Okay. At equilibrium, from equilibrium chapter we have learned these concentrations are equal to Kc, right? Equilibrium constant Kc. So this we can write it as log Kc. So E naught cell is equals to 0.059 upon N log Kc. Log Kc. So this is very easy formula. Now one question on this. Calculate the equilibrium constant Kc of the reaction. So for this you need to know the knowledge of antilog, and antilog has been completely, even log, antilog of positive numbers, antilog of negative numbers has been completely dealt on Unacademy platform on my profile. So please find the link of the concept in a very easier manner. In electrochemistry chapter I have dealt this. So please go through it and refer your friends as well. Given E naught cell is 0.46 volt. So we need to find Kc of this particular reaction. So what all we need here? We need N value, we need E naught cell value, and we can calculate Kc value. So number of electron changes in this reaction is 2. Solution. Okay. So E naught cell 0.46 volt. Formula is right here in front of you. 0.059 upon 2 log Kc. So this would be 2 into 0.46 volt divided by 0.059 is equals to log Kc. Now from here what value you get? Let me just check. I think 15 point something. 2 into 0.46 divided by 0.059. Yeah, 15.59 volt. That is equals to log Kc. But we want only Kc. So here log Kc, what we have got here is 15.59 volt. But Kc would be 1 upon log. Log should come this side, then only we'll get Kc. 1 upon log 15.59 volt. 1 upon log is nothing but anti-log. Anti-log of 15.59 volt. So anti-log of 15.59 volt is 3, whatever is there. So let me just tell you, whatever is there before decimal, you can take it as power. In short, let me tell you how to calculate anti-log. Before decimal, whatever is there, take it as power. And then go to 0.59 and see 0. Okay. So it would be 3.92. 3.92 into 10 raised to 15. 10 raised to 15 as the answer. Yeah. So that's the short part I could take from this particular chapter. And one more topic I would like to take, that is Gibbs free energy. Gibbs free energy represented by G. Gibbs energy is represented by G. So Gibbs free energy is the energy change that occurs. During a particular electrochemical reaction, and this could be calculated by the formula delta G of a reaction R is equals to minus NF E naught cell Here F is Faraday's constant, that is 96487, and E naught cell, you know that the potential of the particular cell. This is Coulomb per mole. Yeah, delta G is Gibbs free energy, N is the number of electron changes. This is when it is standard condition. If it is in normal conditions, then you can write this NFE cell. Right? One problem on this. The standard electrode potential. The standard electrode potential for Daniell cell. Daniell cell equation you need to remember. It's very important. For Daniell cell is 1.1 volt. Calculate standard Gibbs energy, that means delta R G naught. Okay, solution for this one. Now it is a Daniell cell. Zn plus copper 2 plus gives Zn2 plus copper, right? Number of electron changes here 2. We know formula is delta R G naught is equals to minus NF E naught cell. Delta R G naught we need to calculate. That would be equal to minus 2 into Faraday's constants 96487 Coulomb per mole into E naught cell value given the question 1.1 volt. 1.1 volt. So this would give you answer minus 21227 joule per mole. Joule per mole. If I want to convert it into kilojoule, divided by 1000. So minus 21.227 kilojoule per mole. So if you want to convert joule to kilojoule, divide it by 1000. So it will simply get converted into kilojoules. Okay, right. So one second. Thank you so much, all of you, for joining. And please go for the plus subscription using the code PRKLIVE in order to get 10% off on the plus subscription. Right? So if you have any doubts, you can comment in the comment section. It will be definitely dealt. The entire course, as I discussed or mentioned, that it has been taken in detail on the Unacademy platform that's on my profile. So you can just go through it and see how things have been dealt there, and follow me on Unacademy. Hello Sudhar, good morning Preetham, good morning Yashoda, good morning Ramchandra, good morning Sai Murali. Thank you for joining. Please follow me on Unacademy platform for all the new live classes, right? So if you have any doubts, you can ask me. Okay, so see you on Unacademy platform. Please follow it there to get all the complete course details. Here I have taken all the revision of whatever chapters I had dealt on Unacademy. So I would like to have you all on my class. Yes, so yeah, if you have any doubts, you can just ask me. Yeah, okay, fine. Thank you everyone. Let me just end the class and have a good day.